Welcome all. In today's class, let us see what exactly is enthalpy. And generally we use the equation H is equal to U plus PV. Now some students asked me a question, sir, is this equation applicable for open system or closed system or for both? Or is this equation applicable for reversible process or irreversible process or for both? Let me clear all your doubts, including the physical meaning of enthalpy. Now, so I request you to watch till the end. So if you are not interested, kindly don't watch. There is no problem. I'm not forcing you. But the only thing is, if you want to know all about like reversible, irreversible, open, close, then you have to watch till the end. That is the only request. Right. Let's get into the topic. Now, I have water in this bottle and I have closed it. It's a closed system. Now my system is water. It is a closed system because no mass is entering, no mass is leaving. It is a closed system. Let's see what are the energies associated with closed system. Now please look at, my dear friends, this water bottle I am moving like this. Dekho, let us say I am moving this water bottle like this. Yes. Now you have seen. So when it is moving, I have tracked the path. Let me explain again, my dear students. A second, please. Now observe here. So now we have tracked, a second, please. Now this is the water bottle. Now water bottle is here. Now it's moving like this. Yes. Now look at any point of time, let us see what this closed system energy comprises of. So I want to see what is its energy at this point. So if you take any reference level, it has a potential energy. So as it is moving, it has velocity. So there is kinetic. I am writing the total energy of a closed system. Let me repeat. I am writing the total energy of closed system. This total energy is given by, it has kinetic energy, that is half mv square. So I write half mv square kinetic energy, and it is at some height. So I write it as mgz, that is potential energy. Now we are writing energy of our system, which is water. Don't you think we are missing something? I think we are missing something. What is that? Look at, this is moving. So gross, please look at whatever we have calculated this. Have you entered at the molecular level? No, sirs. You have not entered at the molecular level. These are gross at the macroscopic level. Gross means complete, not individual molecules. That's why we call this as macroscopic form. Macroscopic form. Don't you think we are missing something? I think so, sirs. We have seen this is moving, so we have seen kinetic energy of this. It has potential energy, but molecules also have energy, which we call it as internal energy, which is internal to the system. Molecules translate, molecules rotate, molecules vibrate. They have bonding, chemical energy. So there is some energy associated with molecules. When you are taking the total energy of the system, we have to take everything into account. So therefore, the total energy, all forms of microscopic energy associated with molecules, we call it as internal energy. So therefore, now I write U. And this is nothing but microscopic. Let me repeat, microscopic. So therefore, for a closed system, I repeat, for a closed system, this is a closed system because water is not flowing. It is a closed system. For a closed system, we have, look at, my dear students, we have kinetic potential, which is gross, and internal energy. As I told you that internal energy is the microscopic form, all microscopic forms of energy associated with molecules. No problem. This is for a closed system. Generally, if the closed system is stationary, let us say it is stationary. What does stationary mean? It is neither moving up nor moving down. Means there is no change in potential energy. It is stationary, so there is no change in velocity. Now you may be wondering, so what are you going to do with stationary system? Closed stationary system. What are you going to do with closed stationary system? Let us say I am supplying heat. Who is taking that? Molecules are taking. So will you find any change in potential energy? No. So change in energy in that case for a closed stationary system, the change in energy is change in kinetic, change in potential, change in internal. So if it is a closed stationary system, unlike previous case, in previous case it was moving. So therefore it had gross kinetic energy, gross potential energy and gross there is internal energy. Now if it is stationary, there is no change in kinetic, there is no change in potential energy. There will be, therefore change in energy is only change in internal energy for a closed stationary system. Great. Now what we do is, so please understand, for a closed stationary system, the total energy comprises of microscopic and macroscopic. This microscopic is internal energy, all forms of energy associated with molecules. This is absolutely fine, no problem. Now the same fluid, now let us see. Please listen. Earlier it was closed. Now look at, now it is flowing. It's a flowing fluid. So now I can call this as open system. Is there any difference, sir? So will there be any difference? Now let us see the energies associated with open system. Very good. Now dear students, understand carefully. Let us assume this to be our control volume. Or I am analyzing this portion. The fluid is flowing, say the fluid is flowing like this. When it is flowing, complete fluid, it has kinetic energy, it has potential energy, means it is at some reference height, and already you know it has internal energy. So now the question arises is, sir, you have already told that for a closed system, it has internal, potential, kinetic. Then it is an open system, the fluid is flowing. Is there any additional component coming into picture? Ek second ruko. Now, let us take this portion of the fluid. I repeat, let us take this portion of the fluid which is about to enter. So when it is about to enter, I have taken small element of the fluid. Let the volume, don't get confused. So, chalo, velocity let me represent with C, because volume starts with V, velocity starts with V. So velocity let me represent with C, volume as V. Let V be the volume of the fluid and there is a resisting pressure. Now it has to move. Definitely some work is, let us assume that the area of this, the element is like this, the fluid element is like this. Now its area is A, and let its length be x, and it is about to enter. It is about to enter the control volume. It is about to enter, this portion is about to enter the control volume. Means definitely if the pressure is P here, to overcome that some work is to be done. Some force is to be applied so that it enters. And let us see how much work is done. Definitely you have to do, because what is work? Force into distance in the same direction. So some work is to be done. So therefore now I am applying F. So let us see, if there is no acceleration, so what is the force required? Whatever is the resistance. So therefore let the pressure be P, and what is the force? The force is pressure into area, So this is F. Now what is the work done? And it is to, if you want to cause this element to move completely, how much distance it has to move? So if you want, for example, let me tell you very clearly. 8 seconds, sirs. Let us assume this is the, I am showing you this boundary. This is the boundary of control volume. And this, here the pressure is P, here the pressure is P, and let the volume of this VV. So area into length. Now look at, so how much distance it has to move? If you want this to enter completely, it has to move through a distance of x. Means now I write the work done is equal to PA, that is force, into x, PA into x. What is area into x? So A is the area, x is the length. Area into length is volume of this element which is about to enter. So therefore P into V. And this work we call it as flow work. What is flow work? The work done in causing the fluid element either to enter or to leave. I can show you that in order to cause the fluid element to leave this, the work is again PV. So this we call it as flow work. And some people call it as flow energy. Some people call it as convected energy. Some people call it as transport energy. And they say it is a property, because pressure is a property, volume is a property, combination of properties PV, they call it as property. Chalo, we'll see a little later. So flow work is a property. So therefore PV it is entering. What is PV? इसका मतलब है in closed system you have not found that PV component, but in open system you are finding out PV. Means to cause the fluid element either to enter or leave, some additional component is coming. Now let us see what is that additional component. Just now I told you, means that flow work component is coming. Because of that it is entering. Because of that flow work it is entering. Because of that flow work it is leaving. But in closed system there is no flow work. That's why there is no cross of mass. Means now I can write in open system, my dear students, in open system now I can write, dear students, 1 second please. In open system now I can write that, 1 second please, 1 second please. Right, now absolutely fine. In open system, already you have seen there is internal energy, already you have seen kinetic energy, already you have seen potential energy, but there is, as it is flowing, some work is to be done in causing the element to enter the control volume or to leave the control volume. Means additionally this term is coming. So already you have seen this in closed system. Already you have seen the closed system. If you want to write energy of open system, it is energy of closed system plus additional. Because of this additional term, it is flowing. Now I will write, देखो रे, let me combine U plus PV, okay, plus kinetic energy plus potential energy. My dear students, the kinetic energy, potential energy, what is it? It is macroscopic. It's not at the molecular level. It's not at the molecular level. And this is microscopic, that is at the molecular level. So for convenience, I write this as sum H plus Ke plus Pe. And this is macroscopic and this is microscopic. Oh my God. Let's see the beauty here now. Let's see the beauty here. Dear students, okay. My additional wait, sirs. Now, for closed system, अरे ये भी नमूना है आपकी तरह. Now, for a closed, for a closed system, the total energy is, so energy of the closed system is kinetic energy plus potential energy plus internal energy. What is this, sirs? It is microscopic. Then energy of the open system is what, sirs? Kinetic energy plus potential energy plus U plus PV, and this is microscopic. Now I am defining this as it is microscopic, as it is a combination of properties. Let me define for convenience some H. Now can I write energy of the open system as kinetic energy plus potential energy plus H? Absolutely. Now you compare this. This macroscopic is common. What is the difference? UH means now I will define what enthalpy exactly and physically is. Internal energy is the microscopic form of energy of a closed system. Internal energy is the microscopic form of energy of the closed system, and enthalpy is the microscopic form of energy of flowing system. Internal energy is the microscopic form of internal energy is the microscopic form of energy of closed system, and enthalpy is the microscopic form of energy of flowing system or open system. Now the question arises, sir, we are very happy. The way you said internal energy is the microscopic energy of closed system and enthalpy is microscopic energy. In interviews, if they ask you what is enthalpy, your answer should be enthalpy is the microscopic form of energy of open system or flowing system. Now the question arises, sir G, for convenience you have defined U plus PV as enthalpy, and you have also said we are very happy that it is the microscopic form of energy of open system. Is enthalpy defined only for open system? Sirs, we are not happy. My student said, dear students, this is the definition of enthalpy. U plus PV mathematically and physically. What is physically? Physically, it should be highlighted. I repeat, physically, it should be highlighted. Dear students, physically, it should be highlighted. Physically, what is enthalpy? It is the microscopic form of energy of flowing fluid or open system. Now the question arises is the enthalpy defined only for open system? So what is the mathematical equation of enthalpy? H is equal to U plus PV. This is mathematical definition. And what is physically? Microscopic form of energy of flowing fluid. Now one student asked me a question. Sir, क्या enthalpy सिर्फ closed open system के लिए define किया जाता है? Is the enthalpy defined only for open systems? The answer is no. If it is no, then I have to explain that I have to show you what enthalpy is representing in closed system also, na? Great. This word enthalpy was first coined by Robert Mollier, M-O-L-L-I-E-R, Mollier. The Greek word of this is actually enthalpian. Enthalpian. From this word, the word enthalpy was coined and it was first given by Mollier. That's why, my dear students, in Mollier diagram, you'll be seeing Hs because this enthalpy term was first given by Mollier. That's why in Mollier diagram you see enthalpy. Sir, ये सब सही है sir, historical background क्यों चाहिए? हमें physical meaning चाहिए. चलो ठीक है. Now you know that for open system enthalpy is what? It is the microscopic form of energy of, so all forms of energy associated with open system, because in closed system there is no flow work, but in open system there is flow, internal energy के साथ साथ there is flow work. So when you add internal energy plus flow work, that will give me enthalpy. Great. Now let's see the beauty here. Mostly this term was used by chemical engineers during chemical reactions, enthalpy of formation. They use chemical engineering students, they use this. Now let us take closed system and see the beauty of enthalpy in a closed system, because already in open system we have seen U plus PV, flow work plus the work which is used in causing the fluid element to enter plus internal G. That component is enthalpy for open system. So now I'm not saying that it is defined for open system. No. It is a general term. Let's see now. Let us take a container. In this container, let us take a fluid, maybe liquid, maybe gas. For a moment, let us assume it is massless. For a moment, assume this to be massless. And you know, the atmosphere is exerting pressure. If you draw the free body diagram of this piston, I repeat, तो क्या होगा sir? Inside the fluid is exerting the pressure. It is in equilibrium, sirs, and this is massless. So mass is zero. इसका weight zero होगा because it is massless, and there is external pressure, that is atmospheric pressure. Let us heat it. Now you tell me, is it a closed system or open system? Is it a closed system or open system? It is a closed system because inside fluid is neither leaving nor any additional fluid is entering the system. My fluid is a closed system. Wonderful, sirs. Let us heat it. Let me supply Q amount of heat. Now, observe clearly. Can I say it is a constant pressure process? And let us say the piston is moving at a uniform velocity. When I am heating, let us say the piston is moving at uniform velocity. It means there is no acceleration. That means when there is no acceleration, net upward, net dynamic equilibrium, net upward, net downward is equal. Therefore, so now fluid pressure is equal to atmospheric pressure. So my atmospheric pressure is not changing. That's why the fluid pressure is same pressure. So we are carrying out at constant pressure. Now the question is, sir, why are you taking constant pressure? Dear students, in chemical engineering, most of the reactions, you take a beaker and in beaker, it is open to atmosphere. Now some chemical reaction is going on. At what pressure it is going on? Atmospheric pressure. So most of the processes are carried out under constant pressure conditions. That's why, so you know very well, when most of the things are going on at one particular conditions, we prefer that. ऐसा कोई rule नहीं है. There is no hard and fast rule, but as most of the things are happening under constant pressure, so therefore I prefer this. Now, look at sirs. You know, from first law of thermodynamics, d dash q is equal to du plus d dash w. So let me use this for a closed system. And these two are inexact differentials. These two are not properties. These two are path functions. And energy, internal energy is a property and it is a point function. Now, look at my dear students. It is a closed system. Great. Now d dash q is equal to du plus work. What is closed system work? It is PdV. Now one student says, sir, you are misleading us. Then I ask why. Sir, this is strictly valid for reversible process. Does it mean that you are carrying out a reversible process? Yes. For a moment, yes. For a moment, yes. Let me show you all the things. For a moment, yes. Let us say there is no friction and in a quasi-static, frictionless, beautifully slow manner I am carrying out. It is a reversible. So if it is reversible, for a closed system undergoing reversible process, work is given by PdV. Be careful, sirs. I cannot use PdV for any closed system process. It should be applied only for a closed system undergoing reversible process. For a moment, let us assume that it is reversible process. Exactly. Now, so let us see what is the heat transfer. So heat transfer is equal to du. Can I write du as u2 minus u1? Yes. Now, here the pressure is constant. Here the pressure is constant. Let us assume that when I supply heat, the piston is moving upwards. Let us say this is the initial volume. After some time, the piston is here. Great. It means now there is a change in volume. So original volume was V1. Now afterwards the volume is V2. So let me write du is u2 minus u1 and you know the pressure is constant and thereby I'll write this as change in volume. So whatever the heat you have supplied initially, a second please, I'll make it very clear, sirs. I'll make it very clear. Do not worry. Do not worry. There is a system. Let the volume be V1 and now I am heating. Afterwards, let us say this is the volume V2. I am supplying heat and what is constant? The pressure is constant and it is moving slowly in a quasi-static manner and there is no friction, therefore it is reversible. So therefore d dash q is equal to du plus d dash w. So now can we write this as P? P, what does P represent? It is undergoing at a constant pressure. So du is u2 minus u1. u2 is this internal energy, u1 is this internal energy. As it is a property, it has that value at a particular state. So final minus initial, okay, plus work. Reversible closed system and moreover constant pressure. Work is given by PdV for a closed system undergoing reversible. So now here work is given by P. P is constant. What is the change in volume? V2 minus V1. Why the volume is changing? Because you are supplying heat. So can we write this as PV2 minus PV1? Yes sir, the work is given by. But whether it is P1 or P2, the pressure is same. Whether it is this pressure or this pressure, whether it is P1 or P2, it is a constant pressure, therefore I am writing. So can we write P as P2? Can we write P as P1? Yes, my dear students. So P2 V2 minus P1 V1. Absolutely. So D dash Q is equal to U2 plus P2 V2. Excellent. Minus, you take minus common, U1 plus P1 V1. So what is this? Already have defined enthalpy. U plus PV is enthalpy. So therefore D dash Q plus E is equal to H2 minus this is H1. What is the system? Closed or open? It is a closed system. So you have seen enthalpy for open system. Now it is a closed system. Don't think that enthalpy is valid only for open system. It is a closed system. For a closed system, what is enthalpy representing? The change in enthalpy is representing the heat transfer. So for a constant pressure process, the heat transfer is change in enthalpy for a closed system. Matlab enthalpy concept I can use even for closed system. So therefore एक बात clear हो गई. So one point is very clear. So enthalpy term I can use for closed, I can use for open system. In a closed system, when it is a constant pressure process, the heat transfer is change in enthalpy. Now the question that comes to his mind is, sir, is it only for constant pressure? Predominantly most of the processes are occurring at constant pressure. Therefore I have used this. What's wrong in this? That's why, my dear students, some people call enthalpy as heat content of the system. But it means when they use the word heat content, it means they are referring to closed system. When they say microscopic form of energy of flowing fluid, they mean that it is applicable for what? Flowing system, open systems. So don't get confused, sir. मेरा mathematical formula तो एक ही रहेगा. My mathematical formula is same, that is U plus PV. इसमें कोई फर्क नहीं है. There is no change. So now, again one student asked me a question. Sir, you are very smart. You are playing with us. So initially you started with open system. Now you have given for closed system. We are very happy that the term enthalpy I can use for open closed. There is no problem. Then I said, what is the problem? Then he said, sir, you have used PDV, but PDV is valid only for closed system, reversible, closed system reversible. But can I say that if it is a closed system, I can apply only for reversible? Now see the beauty. Now you will see the beauty. Till now I took reversible. Now I'll take irreversible. Closed system reversible we have discussed. So H is equal to U plus PV I can use for as the heat transfer in a closed system reversible. Just now you have seen. Now let us take irreversible. Dear students, let us take irreversible and see whether I get the same or not. देखो एक बार. Let's enjoy, sirs. Let's enjoy. आराम से. Let us take the piston cylinder arrangement. Now, there is a huge friction here. The piston is moving at a uniform velocity, no problem. There is a huge friction here. Look at carefully. Actually, if you see the view of the piston is like this. This is the piston. Now, this is the area, if the diameter, this is the area. On this, the fluid is exerting, and definitely it is a constant pressure process. Dekho, it's a constant pressure process, no doubt about it. Ek second. Dekho, sirs, aaram se, no tension. Dekho. Look at what is the pressure. Let us say it is massless. Assume this to be massless, and this is atmospheric pressure. Absolutely fine. Now inside the gas is exerting. As this is massless, for equilibrium, whatever the fluid pressure is there, the same is atmospheric pressure. When I heat, the piston is moving at a uniform velocity. Assume that it is uniform velocity. There is no acceleration. So for dynamic equilibrium, this and this will be same. So can I say? Now there is atmosphere here. Observe clearly. Dear students, बहुत carefully सुनना. So can I say this as the force is given by P ATM into A? Can I say the force is given by, because this is acting on this complete circular area. Piston is like this. This is the piston. Look at, this is the piston. Now the piston is moving. So on this area, the atmosphere is exerting. So what is the force? P atmosphere into this area. Absolutely fine. Now, let us heat it. There is a huge friction here. Now what will happen? It is moving. Definitely, it is not reversible. It is irreversible. There is a friction. Now I heat it. After heating, say the piston is somewhere here. Let us say it has traveled through a distance x. Listen carefully, sirs. This is the original volume and this is the final volume. Can I call this as change in volume? Can I call this as change in volume? Yes, my dear students. Can you give me what is change in volume? Dear students, can you give change in volume? It is this volume. Can I write it as area? This is original volume and finally it is occupying this volume. What is the change in volume? It is this volume. So area into this length. So area into this length. Exactly. Can you tell me what is the work? Dear students, work is not just defined for reversible. Work is defined for anything. What is the general definition of work? It is the force into displacement in the direction of force. In the direction of force. Therefore, F into X. Now the fluid is exerting force, the pressure, and it is moving. So therefore, F into X. Therefore, how much distance it has moved? X. F. What is F, sirs? What is F? What force it is overcoming? PATM into area. PATM into area. PATM into area. That is the force. PATM into area. Exactly. Force into X. Into X. What is X? X is, X second please. Oh, sorry. PATM into X. I'm really sorry. Okay. So therefore, the work is given by PATM. What is AX? V2 minus V1. Is it not the same, sir? Now, dekho ek baar. But here, this pressure and this pressure is same. So, therefore, I'll write this as P into V2 minus V1. So, dekho ek baar. D dash Q is equal to, D dash Q is equal to du plus D dash W, or heat transfer at constant pressure du is U2 minus U1. Again, the work is nothing but it is P into V2 minus V1. I can write this as P2 V2. I can write this as P1 V1. So, D dash W, the work is given by PV2 minus PV1. So, therefore, P2 V2, pressure is constant, P1 V1. Again, it is U2 plus P2 V2 is H2. Again, U1 plus P1 V1 is H1. So, again, it is the heat content. So, for a constant pressure process, now you may get confused. Sir, I'm getting the same equation for reversible and irreversible, that is P into V2 minus V1, P into V2 minus V1. See the difference here. Let me tell you what is the difference exactly, my dear students. So, let me tell you what is the difference here exactly. The difference is, please try to understand. Please try to understand. The difference is, if it is reversible, for the same heat, definitely the distance traveled will be more, so therefore more output is obtained. But the equation is P into V2 minus V1. But for irreversible, even though the equation is same, very simple definition. For constant, I'm talking only for constant pressure. I'm talking for constant pressure. So even though the equation is same, P into V2 minus V1, very simple, sir. How did you get the, for reversible it is PdV. You have written, therefore you wrote P into V2 minus V1, you got for reversible. But for irreversible, I have gone from fundamental equations. What is fundamental equation? The force is PATM into A. PATM into A. So therefore, how much distance it has moved? X. So therefore, work is given by PATM AX. Force into distance. Okay, but what is AX? AX is change in volume. Therefore, it is PATM into change in volume. So therefore, again you are getting atmospheric pressure is not changing. PV2, PV1. So heat transfer is given by U2 minus heat transfer is given by du plus d dash w. Du is U2 minus U1 and the work is PATM into V2 minus V1. So therefore you have U2 plus P2 V2, U1 plus P1 V1. Again it is change in enthalpy. It is a closed irreversible. So the beautiful conclusion here is H is equal to U plus PV is a generalized equation. What is that generalized equation? I have shown for closed system, I have shown for open system. You can apply for reversible, you can apply for irreversible. There is no condition at all. So this is the generalized equation H is equal to U plus PV. Now in interviews, they may be asking you, what is the physical meaning of enthalpy? So you should tell in two ways. So it is the microscopic form of energy of a flowing fluid, whereas internal energy is the microscopic form of energy of a closed system, whereas enthalpy is the microscopic form of energy of open system. Then they say, is it defined only for open system? No. Sir, it is also heat content. If I am referring to closed system, it is the heat content. What does it mean? In a constant pressure process, whatever the heat is supplied, it is equal to change in enthalpy. So this is the beautiful. So finally, if I sum up all the things, I can say all about enthalpy. First, it is the microscopic form of energy of open system. Or when they ask you, is it defined only for open system? No, you should tell that it is the heat content. What does it mean? Sorry, heat content. What does it mean? It is equal to the heat transfer at constant pressure is equal to change in enthalpy. Change in enthalpy. Can I apply for open system? Yes. Can I apply for closed system? Yes. Can I apply for reversible? Yes. Can I apply for irreversible? Yes. So the generalized equation is mathematically it is U plus PV and physically it is microscopic for open and it is the heat content for closed system. And mostly we'll be using this in our refrigeration, air conditioning, power plant. So एक छोटा सा point बता के I'll close it. I'll show you a small point and I'll close it. Look at my dear students. What is that? You know that H is equal to, I repeat, last one, you know that H is equal to U plus PV, exactly. You know that H is equal to U plus PV, okay. Now DH is equal to DU plus PdV, differentiate this, DU plus PdV plus VdP. Let us take solids, देखो, I can define for solids, liquids, fluids, anything. So let us, you know that for solids and liquids, generally they are incompressible. What does incompressible mean? Incompressible mean the change in volume is zero, or the change in density is zero. Incompressible, the change in volume is zero. So for solids and liquids which are incompressible, the change in volume is zero. So dH is equal to du plus vdp. Listen carefully, sirs. Most of the processes are for, so I'm talking about not gases. Now this is specific to, yaar, you can define enthalpy for solids, liquids, gases, anything. But now I'm specific to solids and liquids. I'm specific to incompressible. अब gases हटा देना, थोड़ी देर के लिए gases को हटा देना. For some time remove gases. So now you have du plus vdp. And if pressure is constant, for solids and liquids, I'm talking for solids and liquids, change in pressure is zero. That's why the change in enthalpy is equal to change in internal energy. So please note down that. So as for solids and liquids, the change in enthalpy is change in internal energy. And let us say, look at my dear students, look at my dear students, ये हो गया आपका. And one more thing, most of the times, you know, internal energy is predominantly a function of temperature. So if in pump, we pump the liquid from one pressure to other pressure, low pressure to high pressure, and what is the temperature there? It is constant. So therefore internal energy is predominantly a function of temperature. So when you are pumping, the temperature is almost constant. When the temperature is almost constant, internal energy is almost constant. So therefore in case of pumping, the change in enthalpy is equal to vdp. So generally I can say that that's why in pumps, what is the pump work we call? Change in enthalpy, that is vdp. So to sum up all, what is physically enthalpy? It is U plus PV. And last, the beauty. The last beauty is, one student again asked me a question, sir, आपने enthalpy directly U plus PV लिखा. We can visualize U, but how suddenly PV came? We can visualize U, but how suddenly PV came to your mind? The explanation can be given something like this. At absolute zero, the question is now how this PV came into picture. Now, at 0 Kelvin, you know, there is no molecular activity, the volume will shrink to zero, almost zero, something like this. Almost. I'm not saying zero, almost. Now, let us say my enthalpy is, there is a system. These are my molecules. Let us say this is my system. This is my system. I'm writing U plus PV. Its pressure is P, its volume is V, and its internal energy is U. Now I can explain something like this. I can think of the explanation like this. If it is at absolute zero, it's almost shrunk to zero volume. Almost. I'm not saying zero because zero volume is koi mass hi nahi. So almost. So now to create this, it has to do some work. Already we have seen flow work. Already it has internal energy. To create from this state to this state, it has to do some work. And that work is PV. So therefore, from here to here, if you want to see, you are getting this term PV. That's why already it has internal energy. But from this position to this position, it has to do some work, that is flow work, PV. Therefore, we are adding PV. So last but not the least, एक बार sum up करेंगे. It is the physically enthalpy is the microscopic form of energy of flowing fluid, or it is the heat content when I refer to closed system. Thank you, my dear students. Hope you have enjoyed. So we'll come up with very more good concepts. Thank you. Good luck.